focus on solving rational equations. This is going to be a two-part lesson. The second part will be on radical equations, but today we're going to solve mainly rational equations. When I'm looking at the equation x minus 8 over 3 plus x minus 3 over 2 equal to 0, the easiest way to go about this is to eliminate the denominator by finding a least common denominator. So to do that, when I look at 3 and I look at 2, I see that my least common denominator would have to be 6. So I'm going to multiply everything by 6. When I take 6 times my first piece here, I'll have 6 divided by 3, which is 2 times the quantity x minus 8. Plus, when I take 6 times the second piece, I'll have 6 divided by 2, which is 3 times the quantity x minus 3. And 6 times 0 will still be 0. This looks much nicer to solve. Further, I can now distribute to have 2x minus 16 plus 3x minus 9 equal to 0. Combining like terms, I have 5x minus 25 is 0. Add 25 to both sides, and then divide by 5. And it's okay for x to be 5 since x can be all real numbers. Notice there are 0 x values in the denominator, so there's nothing we need to worry about there. So x equals 5 would be our solution. Now in comparing this last problem with 1 over x plus 1 over 2x plus 1 over 3x, and I'm looking at all of my denominators, I know that my least common denominator is going to have to be 6 when I just look at the numbers, but in addition they each have a single x, so it has to be 6x. And I also need to remember that x cannot be 0, because if I replaced x with 0 in the denominator, that would mean that we would have a 0 in our denominator, which we know can't happen. So as long as I get any other value besides 0, I'm okay. Again, I'm going to multiply everything by 6x. When I take 6x times 1 over x, our x's will disappear and I'll be left with 6. And if it helps you, since there's a lot of moving parts here, perhaps we could say it's 6x over x plus 6x times 1, so I'll have 6x over 2x plus 6x over 3x equal to 30x. Now I see that my x's will disappear here, 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 and here, since they're common factors. And then when I simplify each fraction, I'll have 6 plus 3 plus 2 is 30x. Adding them all together, I have 11 is 30x. Divide by 30, so I see 11 30s is equal to x. Since it's not equal to 0, we're okay, and we can say that 11 30ths is our solution. In this next one, notice we have a binomial in our denominator, but it's the exact same binomial. So when I look at my least common denominator, they both have the binomial x minus 3. And when I'm looking at x minus 3, I know that x cannot be 3. So as long as I get any other number besides 3, I'll be okay. Again, I'm going to multiply the whole thing by that common denominator. This provides me with x squared times x minus 3 over x minus 3 equal to 9 times x minus 3 over x minus 3. Each pair has a common binomial that we can eliminate. So we have x squared is equal to 9. When I take the square root of x, we know that x would be equal to plus or minus 3. we have the possibility of positive 3 and negative 3. We said that x could not be 3 here, so we're going to eliminate this option because that won't work. The only one that works in this situation is x equal to negative 3. In example 4, our binomials are different in the denominator. So our common denominator is going to have to be each one of those. So our least common denominator has to be both x minus 1 and x plus 2. And I have to keep in mind what x cannot be. So x cannot be 1 on the left, and x cannot be negative 2 on the right. So again, as long as we get any other numbers besides those, we'll be okay. So now I'm going to multiply each numerator, each part, by x minus 1, x plus 2. So I'll have 2 times x minus 1, x plus 2 over x minus 1. We'll do the same to the right-hand side, so 3 times x minus 1, x plus 2 over x plus 2. Simplify, we have common binomials in the numerator and denominator as factors. So we have 2 times x plus 2 equal to 3 times x minus 1. We can distribute both sides. I can go ahead and add 3 to both sides. So I have 2x plus 7 is equal to 3x. Subtract 2x, so 7 is equal to x. Notice that 7 is not 1 or negative 2, so we're okay there. This next example, we're going to have to factor our denominators a little bit so that we can identify what our common denominator might be. So I'm going to individually factor the denominator. I'll have 3 times x plus 2, a difference of perfect squares, x plus 2, x minus 2, and then I have x minus 2. So looking at my least common denominator, it's going to have a 3. I see that a couple of them have the x plus 2. We only need one of them since each one only has at most one x plus 2's. And at most, a couple of them have an x minus 2. So I'm going to multiply each numerator by that common denominator. So we'll have, 2 times 3 would give us 6. X plus 2, x minus 2 over 3 times x plus 2. 3 times 1 would still be 3 times x plus 2, x minus 2 over x plus 2, x minus 2 equal to 4 times 3 is 12 times x plus 2, x minus 2 over x minus 2. Now we can go ahead and eliminate common binomials that are common factors. So 6 divided by 3 would be 2, x plus 2, x minus 2, and here. The only thing that's left is to take 2 times x minus 2 plus 3 equals 12 times x plus 2. Distributing, I'll have 2x minus 4 plus 3 equals 12x plus 24, or 2x minus 1 equals 12x plus 24. I'll subtract 2x from both sides, so I have negative 1 equals 10x plus 24. Subtract 24, I have negative 25 is equal to 10x. Or x is equal to negative 25 tenths. Simplified is negative 5 halves. I forgot to mention up above that x cannot be positive 2 or negative 2 for each one of those. So because we got a value that was not positive 2 or negative 2, we are simplified. Let's try another one where we have to factor the denominator. Factoring 5, I'll have 5 times x plus 1, and then another difference of perfect squares, x plus 1, x minus 1. So when I look at my least common denominator, it's going to have a 5. At most, each one has an x plus 1, and at most, each one has only one x minus 1. Keeping in mind what x cannot be, so I don't forget this time, x cannot be negative 1 or positive 1. Either one would result in a 0 in our denominator. And then we'll go ahead and multiply each numerator by this 5 times x plus 1, x minus 1. That will give us 10 times x plus 1, x minus 1 over 5 times x plus 1. 15 times x plus 1, x minus 1 over x plus 1, x minus 1. And 20 times x plus 1, x minus 1 over x minus 1. Simplifying, 10 divided by 5 is 2. Our x plus 1s, our x minus 1s disappear in the middle, and then our x minus 1s disappear on the far right. I have 2 times x minus 1 minus 15 is equal to 20 times x plus 1. Distributing, combining like terms, so 2x minus 17 is 20x plus 20. Subtract 2x, I have negative 17 equals 18x plus 20. Subtract 20, negative 37 is 18x. And divide by 18, so x is equal to negative 37/18. Notice that negative 37/18 is not 1 or negative 1, so our answer is good. If for some reason that your x value matches the x that it cannot be, it can't be included, and if there's no other options, we would say that there's no solution. But this concludes how to solve rational equations for part 1 of this lesson.